celebrate a life so grand. Hey, mister, read that fairy tale again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. A gentle breeze blows across the ocean, sending waves that crash upon the sand. Hey, mister, did you watch Slow Down again? There is time for you to smell the flowers, even though the thorns get in the way. Hey, mister, what's your theory for today? Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day.
Oh, come on outside, ladies and gentlemen, boys and girls. What you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Here's a tale of a suburban housewife who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all, and when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day. Ooh, I've seen.
Hello, hi everybody. Couple of problems there about getting set up, but I think we've overcome the problems now. So we're just a bit late coming on. I think 20 minutes late. So hopefully everything's working all right. I've just got to check now whether my sound's coming through properly. So. Yeah, I think the sound's coming through all right, so that's good. So one of the problems on this is that you can turn the microphone off here, and that's fooled me a couple of times. So before we start, let's say give us if you can donate money, that would be nice. So we have a fundraiser.
Hello everyone, I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. Thank you, and keep up the amazing work that is driving science forward.
So, hello everybody. So, sorry for the mix-up we've had. Weren't sure whether a talk was starting today. I went out because I wasn't sure whether there was a talk starting, and then it's sort of like, oh yeah, it is starting, so I had to rush back. So my wife is going to hairdressers, and sort of like, there's no talk today. Take to the hairdressers. It turned out there was a talk. Anyway, get on to it. I normally check the slides before starting the session, but I'm a bit behind here today, so I'm going to add the slides now, see what happens. There you go, there's the slides. What I find sometimes is the slides get a bit messed up when they put them on StreamYard, so normally I check through them first, but today I've not been able to. So hopefully everything's all right. Got my fingers crossed now that everything's all right, and all the problems are behind me and not in front of me. So what happens is I've been spending lots and lots of time complaining about Einstein's relativity, but of course I could complain about quantum physics as well. The same thing that applies to relativity also applies to quantum physics. They don't seem to teach quantum physics properly. They don't, in the same way they don't teach relativity properly. So it's just to carry on, the whole of physics is really just messed up. So today, the question is, did they lie about the double slit experiment? And it should be a question mark on there. And the question is, when they teach physics students, do they lie? When they teach physics students about quantum physics, do they lie to them about the double slit experiment? And of course, in my point of view, the answer is yes. So, going with that perspective on things, if you've gone through a standard physics education and they've taught you about quantum physics, what they told you wasn't correct. In the same way, if you've done relativity course as a physics student, what they taught you wasn't correct as well. So the whole of physics is a total utter mess when it comes to teaching the subject. So next slide. So as pointing out, I spent many of these sessions criticizing Einstein's relativity, but the same thing, much of it applies to quantum physics as well. Mainstream is just overall a total mess. And the cat's bullying me now. So the cat, I don't know if you can hear that. The cat is telling me it's time for food. So hopefully I can ignore her. But anyway, it's just that criticizing relativity is easier than criticizing quantum physics. Criticizing quantum physics is a much deeper problem, and it's ideally the mainstream should accept the criticisms of relativity, put those right, and then we could then go on to trying to correct quantum physics. But as it is, the mainstream defends the mess in relativity and refuses to tidy things up there. Okay. I think the bottom bit of my slide goes missing. I think I heard my wife come in, so she can sort the cat out. So the experiment to look at in this particular session will be the double slit experiment. Hold on a minute. Cat wants some food. Oh, good. Okay, I'm doing a session. Okay, so I've offloaded all my duties. So this experiment, the double slit experiment, is supposed to show wave-particle duality, and it's one of the many mysterious things in quantum physics. There are lots of mysterious things in quantum physics. But the actual experiment, doesn't show wave-particle duality in the way the educators say. It seems to be just the educators dumbing things down, for their students. So they dumb things down for the students, try to make it easy for them to understand. And what a dumbing down process is, they completely distort the real parts of what the experiment is showing. And it translates into my way of talking about things. They lie to the students. And the students, well, most of them, they're just interested in passing the exams. So they're just being fed all this information, which is wrong. And the students, all their concern is to pass the exam. So they're feeding back this false information in the exam. So what I want to do is show this video. And I don't know if it's on the next slide. So here we go. No. So I'm going to show that video. If I call that up, hold on a moment. Share screen. Biggest lie. There we go. Share. So, hopefully that's there. Hopefully we're going to be able to hear it. So if I turn my sound off, I think that's one of the things that stops the sound coming through properly.
There is a lie about the double slit experiment that's told by everyone, from famous physicists to YouTubers, and even me. What it is, when you shoot electrons at two slits, if you don't watch which way they go through, they'll act like waves. But if you do watch which way they went, then they act like particles. They go straight through, and the results of the experiment, and it's completely but this lie has been told so often that it's kind of got a life of its own. The real lesson of this experiment is way more interesting, and I want to tell you about that. But first, let's find out what the electrons actually do when you observe them, because it's not this. Imagine that we do have a bunch of particles like this that are going to go through this double slit experiment. You expect to have like two bunches of particles. And actually, these slits are very narrow and very close together. So you'd kind of expect a bit of overlap between those two heaps. But here's what would happen for a wave. Okay, so I love this website because it's a wave simulator, and I'll link it in the description. But basically what we're doing here is we have this wall with two narrow slits, and we're going to see what happens when these waves go through. Okay, so what you're seeing happen here is that there are these two waves coming from each of the slits, but when they touch each other, something weird happens. They interact with each other and kind of overlap. And if we let this go further, these interference patterns always kind of look like this, where there's a very strong bit of wave in the middle, then there's not much, and then there's more wave, and then again, there's a blank spot, and then another strong spot, etc. And as we saw in that simulation, what you'd expect for a wave is that it hits this back wall in this very funny pattern. There are some spots like this one where it's very intense, and then there's some spots like this where it's not intense at all. And there are these little bands of, intensity and no intensity. And when you do this experiment with light, that's exactly what you see, which suggests very strongly that light is a wave. In fact, the double slit experiment was the thing that really convinced people that light is a wave after all. And I've done the double slit experiment in a couple of videos before, and I always get a lot of comments being like, this is just classical optics. And that is true. But then they say, therefore, it's irrelevant to quantum mechanics. And that I disagree with. And I'll explain why a little bit later. But first, let's think about the same experiment with electrons. Is it going to turn out more like the particle case or more like the wave one? Well, this is footage from an actual double slit experiment using electrons. So let's see what the answer is. Well, it's looking very promising for particles because unlike with a wave, the result isn't just sort of smeared out. It's coming in these individual dots. But if we let the pattern develop, you start to see that it actually isn't in two. It looks much more like the double slit interference pattern for waves. So something really odd seems to be happening with these electrons. There seems to be some sort as dots. It isn't smeared out the way that waves usually are. But this feels wrong, because for something like light, we're used to thinking of them as little bullets like this, little particles of these slits at the same time. That's why it's really natural to think that if electrons really are going through both slits, then maybe let's try and catch them in the act. Let's put electrons doing both things at the same time. But measurement in quantum mechanics doesn't work like that. So in quantum mechanics, when you try and measure an object that's in a superposition of two different things, like this electron going through both slits, then you will see a particular result. For example, this detector might see an electron go by. But now in quantum mechanics, what happens is that measurement changed the electron. Now it's only going through one of these slits, the one you observed. So far, this is all correct, but here comes the myth. Many people will tell you that now that the electron has been measured, it becomes a particle. And so this particle will act like any normal particle, will sort of end up here. And so you can imagine that if we keep measuring which way every electron goes, then you end up with two piles of electrons. People will draw the results just like this, as two clumps, or at most as two overlapping clumps. And so before I ever did these experiments myself, I assumed that this is what happens. But that's not at all the case.
And I'll get a curve that will probably look more or less like this.
I wish I had experimental footage of someone actually doing this experiment with electrons to show you that this is not what happens. But I don't, and I also can't do this experiment myself because working with electrons is really hard. You need like a vacuum pump and everything. But the results that you get when you do the experiment with light are very, very similar. And so I did that experiment in my previous video, and this is the result that I got. What on earth is this crazy pattern? It doesn't look anything like two lumps. This is actually called the single slit interference pattern, and it's still very much wave behavior. Let me show you. So this is what the interference pattern looked like with the two slits here and here. But what happens if we take that away and instead just have one slit? So here I can change this from double slit to single slit, and let's see what happens. Okay, so it's much less distinct now, but you can still see some funny pattern goes. You can see that there's like a funny sort of edge effect on both sides. And that edge, these two edges are what are going to interfere with each other. So the edges of that single slit interfere so that you get this kind of weird interference pattern. It looks quite similar to the
Okay, so there's a great deal more to that, but that's what I wanted to get to, and it's pointing out that with a single slit you still get an interference pattern, and I think that's not the way I've been taught it when I've done quantum physics. They teach you that when you've got two slits you get an interference pattern, but they don't tell you that with the one slit you still get an interference pattern. So it's on when it's presented to you, it's this mysterious thing of when you got one slit, it's particle behavior, and when you've got two slits, it's wave behavior. So, and that's totally false. It's when you've got one slit, you've still got wave behavior, and you've got the interference. So, the way they're teaching, the way they're teaching quantum physics is they're just lying to the physics students. They've dumbed it down, and basically what they've dumbed down is a misrepresentation of an experiment. And presumably, if they were to go on for higher levels with a master's degree or a PhD, they would then point out to them that what they were taught at the bachelor's degree level was false. But I don't know if that's really what happens. I'm sort of more familiar with the bachelor's degree level of physics, and that's presented in physics textbooks for degree courses, and it's also presented in popular books on quantum physics. So they're all just misrepresenting experiments like this double slit experiment, and I find that utterly infuriating that that's what's going on. But they're doing it with quantum physics, and they're doing the same thing with relativity theory. The educators think if we can dumb down the subject, then it's easier for the students. But that is, in my view, just lying to the students. And it's having all us dissidents who've gone through some sort of physics education as we come to a conclusion, well, what we've been told is wrong. Well, it is wrong. We've concluded it's wrong. And we've been lied to, basically. So I'll get back to my slides then. And so there are other videos talking about the double slit experiment in different ways. So not only do you need to look at this video I've showed you in more detail, but that would, I'm not going into those because that would confuse things with their different perspectives on things. When physics is taught to physics students, they just dumb things down and don't go into the different perspectives. They present an experiment to the physics students, and they just present their dumbed down version of what's going on, and they don't even talk about the different perspectives you can have on an experiment. So they miss all that out. So it's complete and utter nonsense for what they teach students. And as I point out, it's done in relativity courses, and it seems to be done in all physics courses. And as of course, as per recent sessions, I want to use AI, artificial intelligence, about these things. And my preferred AI is ChatGPT. I think it's better than others that I've tried. So I'm sort of I like to anthropomorphize. If you've seen the film 2001: A Space Odyssey, the computer is called HAL, and you're treating it as if it's a person. The astronauts talking to it treat it like a person. And when I'm talking to an AI, AI doesn't really think. It imitates thinking, but it's best to just pretend that it thinks, pretend that's like a human person telling you things. And so when I refer to it, I say the AI thinks so and so, even though it's only an imitation of thinking. So my first question to AI was, has the double slit experiment been misrepresented by physics educators? And yes, it says, yes, it has. Yes. In some ways, the double slit experiment has been misrepresented or oversimplified, especially in popular physics education and media. So that is the big problem. We're basically, in my terminology, we're being lied to by the physics education system and by the popular physics books. And AI goes on, while the core principles of the experiment are usually correctly conveyed, there are a few common misrepresentations that can lead to confusion. And I'm making sure that I've got everything working right. Hold on, and make sure my voice is coming through properly. Yep. So yeah, I'm back. So I seem to be, my voice seems to be coming across properly. I seem to be okay with this sort of like mess up with the delay in presenting this talk. I don't have anybody in the green room. Nobody sort of knew this talk was going ahead. The advertisements don't seem to have gone out. Anyway, the question is, what way is taught is contrast? I want the way that it's taught contrasted with highlighting the actual physics. And so ChatGPT says, the AI says, the way that double slit experiment is often taught tends to emphasize the mystique and paradox of quantum mechanics, sometimes leading to a distorted or incomplete understanding. On the other hand, the actual physics of the experiment is deeply rooted in quantum mechanics and the principles of wave-particle duality, superposition, and interference. Let's break down how these two approaches contrast. So what's being pointed out here is when they're teaching the subject of quantum physics, they like to make it all mysterious. There's a big mystique around it, and this is all this thing about it's paradoxical how things operate in quantum mechanics with all these particles. It's all presented as mysterious and wonderful and everything, and they don't really go into the proper details. So that's part of the dumbing down process to make it a mysterious thing. So number one, on the wave particle duality, AI is saying about how it's taught, most educational explanations highlight that light and other particles like electrons behave both as waves and particles. The wave behavior is emphasized when the interference pattern is seen, and the particle behavior is emphasized when the detector clicks and registers a particle. The duality is often presented as mysterious, or as all mysterious, all magical features of quantum mechanics, with the claim that light is both wave and particle at the same time in some sense, and that the observer seems to cause it to choose one or the other. So it's all mysterious. The observer influences reality. It's sort of, they've got this quantum entity, and somehow mysteriously the observer doing the experiment makes the quantum entity either behave like a particle or behave like a wave. And that's the usual way it's presented. And now we're going on to what the actual physics is. The term wave-particle duality is a bit misleading. So you've got a stupid term which is going to mislead you into what's really happening. Particles like photons, electrons, etc. don't literally behave as both waves and electrons simultaneously in the conventional sense. And the conventional sense is the distorted way it's to talk to people. Instead, quantum objects are best described by wave functions, mathematical objects that encapsulate the probabilities of finding the particle in different locations or states. And the problem here is mathematical. You've got some mathematics, and the way the subject should be presented is you've got this mathematics, and you've got to try to understand what this mathematics means. And the mathematics is called a wave function. And so straight away, you're deep into the mathematical, trying to understand what the mathematics means. And that's the way that the subject should be taught. But instead, no, they like to present it in, it's all a mysterious sort of thing, and not presenting it as a problem in trying to understand what the mathematics is talking about. Number 2 is the role of observation stroke measurement. How it's taught. The emphasis often placed on the observer effect, the idea that the act of measurement forces the particle to choose one state, such as the particle-like state, or another state, the wave-like state. Some interpretations go as far as to suggest that conscious observation itself affects the outcome. This leads to common misunderstanding that consciousness somehow plays a role in collapsing the wave function or determining the particle state. So the mysterious way it's presented is the consciousness of the observer is affecting the experiment. And well, the actual physics is what actually happens is that when the system's unobserved, the particle behaves according to the principles of quantum superposition, existing in all possible states simultaneously. However, when you try to measure or detect the particle's location, which path information, the wave function collapses and the interference pattern disappears. The collapse isn't a mysterious mystical process tied to consciousness. It's nothing to do with consciousness. It's about the interaction of the particle with the measuring device or the environment, and that idea is called decoherence. Once you attain which path information, the system behaves more classically and the interference pattern disappears because the particle chooses a specific path. So that's what is supposed to be going on. It's complications in the mathematics. And so you're supposed to be straight into the mathematics. And this is what the mathematics is. And quantum mechanics is obeying this bit of mathematics. It's not about all that mysterious stuff about, it's consciousness mysteriously influencing the experiments. So number 3 is about superposition and interference, and how that is taught in popular descriptions. Students are often told that the interference pattern arises because the particle goes through both slits at the same time and interferes with itself. And so, as I hope you understood from the video, that is a misrepresentation. The quantum object is acting like a wave all the time. This explanation is often framed as mind-boggling. It's mysterious. It's mysterious. About these particles. The particle is in multiple places at once, or it knows there are 2 slits and acts as a wave. So it's all mysterious in the popular presentation. Number 3 is about the actual. Next we go on to what the actual physics is. The reality is that the particle's probability wave, described by the wave function, is spread out over many possible paths. Instead of talking about the particle being 2 places at once, it's more accurate to describe it's having multiple possible locations with certain probabilities. The interference pattern arises because the probability waves corresponding to different paths through the slits interfere with each other, just like water waves do. And so that's it. Number 4, simplified versus accurate explanation of the interference pattern. And how it's taught, the students are often told that if you shoot many particles like photons or electrons one by one, an interference pattern emerges over time, which proves that each particle is behaving like a wave. There's a tendency to treat this as a mystical phenomenon that blows our minds, since we expect particles to behave like little balls, but here they seem to behave like waves. And as pointed out by the video, they're all acting as waves all the time. The actual physics is the interference pattern is actually a statistical result of many measurements. Each particle is detected at one position at a time, but the probability distribution of these positions follow a pattern consistent with wave interference. It's not that each particle is interfering with itself, but the probabilities of its different possible locations interfere in a way that causes the observed pattern, and explained by the principle of superposition and so forth. It's just all mathematical. It goes on to more, but it gives the conclusion as follows. When taught at a basic level, the double slit experiment often gets framed as a mysterious paradox that defies classical logic and reality, leading to misconceptions like the role of consciousness in measurement or the way particle duality as a literal description. And that's the popular way it's being taught. The popular way it's being taught is complete distortion. Well, the actual physics, however, is grounded in the mathematical formalism of quantum mechanics, which describes the behavior of particles in terms of probabilities. So if you want to do it properly, you have to go deep into the mathematics of what's going on. So my conclusion on that is the whole teaching of this is a mess. The whole of physics, when they teach it, is a total and utter mess. And so I ask AI, so quantum physics is being taught incorrectly. And AI says, in many cases, quantum physics is oversimplified or misrepresented in introductory or popular level teaching, leading to misconceptions or misunderstandings. And my translation of that is, if they're doing that, then they're lying. That's, in my blunt words, talking about things that they're just lying when they teach these things. And AI goes on, while the core mathematical principles and experimental results are correct, the interpretations and philosophical implications of quantum mechanics are often oversold or distorted, especially for non-experts. So basically, these educators are loving presenting all this distorted way of talking about things, making it all sound mysterious. AI guess says more, but that's the bit I wanted to emphasize, so I'm passing on the rest. So in my view, that means false physics is being taught, and AI says yes, it agrees. This is why I like ChatGPT. It agrees with me. In my way of thinking about things, if you're distorting what you're saying about experiments to physics students, then you're lying to them. And ChatGPT likes to agree with me on these things. And it says, yes, you could say that false or misleading physics is often being taught, particularly in the sense that misconceptions and incorrect interpretations are presented as definitive explanations. And so when they're misteaching all of these things, they're leaving all the poor students with misunderstandings about things and incorrect interpretations of what's going on. While the mathematical framework and experimental results of quantum mechanics are correct, the interpretations of those results often oversimplified, misrepresented, or taken out of context. And which translates to me as poor students are being lied to, in my view, which can lead students to form incorrect mental models of how the quantum world actually works. So poor students are being misinformed. And I think my cup of tea might be cooler now, so hold on a moment. Yes, it's cooler. Pause a moment. And I'm having my cup of tea. So my next question is, since actual physics is different to what is taught, then must conclude mainstream physics is wrong. And AI says, it's understandable why you might conclude that mainstream physics is wrong when faced with the misrepresentation of quantum mechanics and other phenomena in educational contexts. However, the situation is a bit more nuanced. So I'm blunt. My view of the teaching of things like quantum physics and relativity is all being mistaught. And as it's being mistaught, then the physics which students are being taught to believe in, well, it's all wrong. And thus I conclude mainstream physics is wrong. But AI doesn't really want to conclude that. It's trying to bluff it off. It's trying to say, my view on the subject is too blunt. Mainstream physics is wrong, in my view, because of everything I've just told you. It's wrong. they're lying to students, in my view, and that's being blunt. But basically, when you want to talk to somebody who's a politician, a diplomat, and is trying to play around with their words, they don't want to admit that they're lying. They want to bluff things off. So basically, AI is now trying to justify all of this dumbing down to physics students. So basically, AI says a lot more, but basically it does not want to accept that quantum physics is wrong because it's taught badly. From my point of view, it's taught incorrectly to physics students, therefore it is wrong. But that's not an official mainstream point of view. They want their cake and they want to eat it. They want both things. They want their physics dumbed down, i.e. lie to the physics students, and they want that to not mean that their physics is wrong. They want both things. So when asked to go deeper, it gives, let's take a deep dive into the issue of misrepresentation in mainstream physics education and explore both the conceptual missteps and the methodological implications that arise from them. We'll break down the layers involved in this fundamental misrepresentation of physics. So I'm pointing out that the experiment I've been concentrating on in this session is the double slit experiment. That's all been misrepresented, and other experiments I've also misrepresented to physics students. But so really, with concentration on the session, is just the one experiment, focusing on how mainstream physics is taught, the historical development of physics theories, and how alternative models like neo-Lorentzian ether theory can help correct misunderstandings. I'll have me sip of tea a minute. Voice is going again. So my grouch is that these alternative models are not taught to physics students. My grouch with the relativity, when I complain about that, the way it's being taught, is they don't go into alternative models. And I've gone on various courses on it for adults and so forth, and I complain that when they're teaching about Einstein's relativity, they don't actually say anything about ether theories, or we'll talk about Lorentz theory or anything like that. And they come back on that is, I'm just here to teach relativity. I'm not here to teach alternative theories. So in the relativity courses, you're being taught relativity. You're not being taught about the alternative theories. They're not mentioned. You're just being told about the one theory. And the same thing happens here now in quantum physics. They don't talk about the alternative theories to quantum physics. They're just teaching you the one theory, quantum theory. So when it's talking here about you should talk about the alternative theories, well, and it says that can help correct misunderstandings. Well, they don't do that. Physics education on the courses, they don't talk about the alternative theories. They're just presenting the one theory. In quantum physics, it's the one theory, the quantum theory. In a relativity course, it's the one theory, the relativity theory. So they're just letting students form their misunderstandings. So issue number one is conceptual misrepresentation, and the key examples. At the core of the problem, we have the misleading simplifications and misinterpretations used in physics education, especially concerning quantum mechanics, relativity, and the nature of light and space. And it wants to break that down. So it's I'm treating it as a person. It's admitting that these things are not being taught properly. And so the example of things not being taught properly is the wave-particle duality in quantum mechanics, the one we're dealing with. And it's a misrepresentation in introductory courses. Wave-particle duality is often taught in a way that simplifies the concept to light and particles can be both waves and particles, depending on how you measure them. And hopefully you understood earlier about the things in the video. That's not the case. If they're teaching you that, then they're misrepresenting the experiment. And anyway, but if you are taught that way, this leads to confusion about what actually happens at the microscopic level. The idea of light or electrons being both a wave and a particle simultaneously is conceptual misunderstanding. So in the view of the AI, treating as a person, the AI view on it is, if you're being taught that, then you are being taught to misunderstand the concepts involved. And the actual physics is wave-particle duality refers to the mathematical descriptions used to explain the behavior of particles in different contexts. In quantum mechanics, entities like photons or electrons do not literally switch between wave and particle states. And it's often they're trying to get the students to think that's what's going on with the way they misrepresent it. Instead, the mathematical model switches between wave-like and particle-like behavior depending on how we choose to observe or measure the system. The wave function, which describes probability amplitudes, evolves continuously according to the Schrödinger equation. So it's just all getting mathematical. You just have to go deep into the mathematics to deal with quantum physics properly. And that's one of the reasons why it's easier just to attack relativity. Relativity, what they teach about relativity is load of nonsense, and it's easier to attack it. But if you want to attack quantum physics, you're going having to go deep into the mathematics. Next. And so the problem with education, presenting this as a literal duality, can mislead students into thinking of particles as possessing both natures at once in an almost metaphysical way, magical way, rather than as abstract models. I need to make myself larger. Abstract models we use to describe reality. So it's only an abstract model. If you wanted to, you could think, oh, this wave function and so forth, that's not really reality, it's just mathematics. But it's the mathematics that's being used to describe reality. Finish with tea, right. Right, and so next is the observer effect and quantum measurement. And the misrepresentation, well, it's the main philosophy behind when they started quantum physics was the Copenhagen interpretation of quantum mechanics. And that's what's presented in many classrooms. And that's just the act of observation. And the act of observation itself collapses the one-wave function, implying that consciousness plays a direct role in determining the state of a quantum system. So that's the philosophical interpretation being imposed, but they don't go into details by saying there's different other philosophical interpretations. They ignore that. Usually. Actual physics, the collapse is not necessarily due to the conscious observer, but rather to an interaction with the environment. And that issue is called decoherence. Measurement involves interactions that irreversibly alter the quantum system, not because of consciousness, but because of entanglement. That's another complicated issue, entanglement with the environment. The measurement problem itself is still debated and unresolved. So that's another thing they don't point out to students, that when they teach the physics, when they teach these physics students about quantum physics, for instance, they're not going to tell you, oh, certain issues are not agreed upon by the physicists, and they're still debated, and they haven't come to a conclusion what's really going on. They're missing all that out. And the problem in education, teaching that consciousness plays a role in the collapse of the wave function leads students into the philosophical quagmire of idealism and anthropometric interpretations. So it's pushing you towards a certain point of view. It's sort of like they're teaching you these things, and they're misrepresenting things, and it's steering you to think in a certain way. And that is not really what's going on, when in reality it's a technical issue in quantum physics and can be explained with decoherence theory. So they misrepresent experiments. That misleads the students into thinking in a certain particular way about things. Next, for some unknown reason, it goes on to relativity. This session is supposed to be about quantum physics, but it's still the AI system still wants to bring in the problems of relativity. And so it says about time dilation in special relativity, and it's telling me that's a misrepresentation. And I've actually gone into these sort of things in more detail in my other sessions about relativity, but I try to quickly gloss over this now through to these other sessions. It's once again, you have a misrepresentation, and time dilation is often explained as time slowing down for an object moving at high velocity relative to an observer. This concept is framed in a way that suggests time itself is elastic, stretched or compressed by relative motion. The actual physics is time is a relational effect, meaning clocks in different frames will tick differently depending on their motion relative to one another. The clock synchronization paradox and the relativity of simultaneity show that the notion of absolute time breaks down. I've dealt with all that better in other issues, but it's pointing out again that relativity is being mistaught to physics students. And so next issue is the wave propagation, the speed of light. And unfortunately, speed of light, well, that's straight again, you're into the issue of relativity. And I've also dealt with that sort of thing better in my relativity sessions. But once again, AI is pointing out this misrepresentation involved. In mainstream education, the speed of light in a vacuum is presented as a mutable constant independent of the observer or reference frame. So I think that's the usual way it's taught, and was all false, really. And so the actual physics is the constant speed of light is a consequence of Maxwell's equations in the context of a preferred frame of reference, which the ether theory provides. So AI is taking the view that you have an ether, but I've actually talked about this better in other relativity sessions, in the way that the students are being taught the usual way. They're being told there's no ether, and AI is saying no, that's wrong, there is an ether. So I've dealt with that better in other sessions, but once again, it's a very bad education. They're just lying to students from my perspective on things. Not only are they distorting and dumbing down experiments, that effectively means they're being lied to. So number 2, how these misrepresentations influence physics education. The primary issue here is that physics education often focuses heavily on the mathematical formalism of these theories without adequately addressing the conceptual interpretations or philosophical underpinnings. And then he wants to go on to say what's going on here. Going on here, this is wrong. So when they talk about when they're teaching physics, they don't want to deal with philosophy. When they teach physics, what they want to do is they want the educators, they just want to talk physics. But whenever possible, they don't want to go into the issues, and that's part of their dumbing down process again. They're misinforming the physics students about the philosophy behind what's going on. And so next, AI is pointing out the problem with the simplifications. And so complex ideas like superposition, decoherence, and relativity are boiled down to simple sound bites that gloss over the nuanced nature of these theories. So they're dumbing things down, and letting students get the wrong idea of what these complex ideas are. And educators, the aim is to make things digestible for students, but often at the cost of oversimplifying key concepts. Failure to engage with interpretations. Many introductory courses teach the Copenhagen interpretation of quantum mechanics or the block universe interpretation of relativity, but this is just one possible interpretation. So they don't, when they teach in physics, they're trying to just teach usually one interpretation, and they're not offering to the students the opportunity to realize that there is other interpretations than just the one they're being taught. By teaching them as definitive answers without exploring alternatives, students are often left with the impression that these interpretations are the only game in town, i.e. the only game in town is the interpretation they're being taught. And they're not told about there's other interpretations, so the students come away with a misunderstanding that the interpretation they're taught is the only interpretation, when it isn't. There's other interpretations, and that leads to confusion. So what happens with the distortion caused by them misteaching these subjects? What you get is reinforcing dominant paradigms, and the paradigms is the way you think about things. All the students have been going through, and they're being taught just one sort of paradigm, and they're not being made aware that there's other paradigms, i.e. other ways of thinking about things. Since mainstream theories like quantum mechanics and general relativity dominate the field, there's a tendency to reinforce their foundational assumptions without questioning them. So it's being taught to the students, these things, and they're not being allowed to question what they're being taught. They're just saying, this is what you got and what you need to pass the exam. Let's not question it. For example, time dilation and relativity is often taught as if it's an observable slowing down of time, even though the actual physics of it is much more subtle and involves the relationship between events in different frames. So if you go into talking about time dilation, it's really a complicated subject, but they're trying to dumb it down and pretend it's something you can observe. Next. So we're still on relativity, number 3. So it wants to talk about the neo-Lorentzian ether theory, and that's an alternative to relativity, where special relativity is usually taught is there's no ether. And so instead of thinking in terms that there's no ether, you can think of in terms alternative way of thinking there is an ether. And so if you're talking about it from a neo-Lorentzian ether theory, it can provide clarity. But normally that's not what's taught. To counteract the misrepresentation of mainstream physics, we can turn to neo-Lorentzian ether theory, which offers an alternative view that can better match intuitive physical models with experimental results. Let's explore how restoring the ether, a conceptual reversal, is a conceptual reversal. The ether neo-Lorentzian theory argues that there is a real medium, the ether, that the light propagates through, which restores absolute space and time in a manner consistent with classical mechanics. So you saw like all this is going against what they're teaching in special relativity. They're teaching, there's no ether, there's nothing for the light to, there's no medium for the light. And they talk about, there's no absolute space, and there's no absolute time. Suddenly, no, you don't have to think. So they're ignoring telling the poor students that you can actually think about it in an alternative way and bring back these things which are being discarded. And so you can, with that, bring back things like variable speed of light. The speed of light in neo-Lorentzian theory is not constant in the way that special relativity puts it, but it's a variable depending on the motion relative to the ether. This aligns well with Lorentzian ether theory and provides a natural explanation for relativistic effects like the Sonic effect or Doppler shifts. And so when you go into these issues of relativity, which I've dealt with better in other sessions, that I've talked to people who believe in relativity. Some of them believe that there is an ether, and some of them believe that there isn't an ether. And so they're believing in a relativity which has an ether, and others believe in a relativity where there isn't an ether. So it's just utter confusion. So Doppler shifts, educational benefits of the Neo-Lorentzian theory. By teaching ether-based theories, we can reintroduce the concept of a preferred frame of reference in absolute time. This restores the classical worldview that was lost with Einstein as relativity models, but maintains the predictive power necessary to create phenomena like GPS and time dilation, etc. Number 4, reforming physics education for conceptual clarity. And that's to correct the misrepresentation of physics education. We need to teach multiple interpretations. And because at the moment they're not doing that. They're, as I said, if you go for a quantum physics course, they're just teaching one theory, the quantum theory. And they're usually just teaching one interpretation, which is the Copenhagen interpretation, and they're not going to touch anything else. And if you go for a relativity course, they're not going to tell you about the possibility that there is an ether theory, but as an ether theory where you can interpret things differently. So we need to teach multiple interpretations, introduce students to alternative theories and interpretations, and so it's pointing out a few of those theories so they can critically engage the underlying assumptions, clarify the philosophical foundations instead of just presenting the mathematical formalism. We need to explore the philosophical implications of the theories. And that's the end finish. So this is the grouch upon the physics education system. They're just misinforming the poor students. And so when they come to the conclusion that if they come to a conclusion that mainstream physics is wrong after doing their physics courses, well, they're going to just get bluffed off by people who've gone higher with things like master's degree and so forth, who are thinking that what they've been taught at the bachelor degree level of physics is just something that's been dumbed down. So if I can now come out if I can now look, I've got nobody in the green room. I've scared them off. So if anybody wants to come into the green room, I'll put a link up. Where's it? Copy. Green. There we go. I'm putting a link up for the green room. Paste. Here we go. Is it got? Yeah, green room link. Unfortunately, the green room, you can only get about 10 people in there. It doesn't allow more than 10 people, so it's only a limited number of places, unfortunately. So first come, first served. I don't know. Right, that's cool. So most of the comments are people talking among themselves. Yeah. So if you need to put to Roger at the beginning of your comments, I know you're referring to me then. Yeah. So Jim Barson is pointing out one of our dissidents who's sadly not with us anymore, Peter Beckman's book, Einstein Plus Two. And he's probably gone through the mainstream physics education where we've been taught things that were false, bad physics education, and so then he concludes that mainstream physics is wrong. So I'm going through the comments looking for anything. Oh dear. So there don't seem to be anything. I'll just bring up this one. That's it. Show. Right. So this person thinks that thinks light is not a wave, and that destroys the other things like the redshift and so forth. So I suppose you could try to think of light from a point of view where it's only just a particle instead of a wave. But these sort of like issues are not gone into when they're teaching physics. But this presentation has been that light is a wave. When you're doing these experiments like the double slit experiment, that is showing a wave-like characteristic of light. So the mathematics involved from this perspective is it's a wave. Okay. So question on it asks about that. Would you say light is solely particles? So nothing is turning up in the comments as far as I can see. Let's see what we've got in the. I don't think I've got anything in the private chat. Nothing private chat. Good. So that was the talk. That was. Sorry for being a bit late starting off. There's another comment's come through. So this person point of view, math is a description. You can model imaginary systems just as well as ones with math. So, but the claim from the mainstream, claim from the physicists is that maths like the wave function and so forth, that is what they're using for their experiments. But when it comes to the educators, they just misrepresent things. Much different. Right. So I'm free now, so I got another video, I think. Let's see what else we got. Oh, chat. GD. Channel content. I'll just move this from the stage. I don't think I got a video, which I don't think I've shown. Go back to argue about relativity. Right. Okay, so let's see about adding this other video. Oh, that's good. Right. Share screen. Okay, right. Yeah. So I don't think I've shown this video. It's more things about relativity. When you go by the relativity textbooks, there are issues about relativity which the textbooks don't acknowledge. And so by missing these things out, it's another method of distorting relativity when they're teaching it to physics students. Oh yeah, great. Okay. So the title of this talk is Unacknowledged Relativity Issues in Relativity Textbooks. Relativity textbooks are bad. They don't cover many of the basic stroke foundational issues about relativity. This gives false beliefs about relativity. I'm still using ChatGPT as my artificial intelligence Einstein made. It does cover many other relative issues that special relativity textbooks miss out. So the question posed to the AI is, what things are not clearly checked? And ChatGPT says that's a deep and important question. Many standard relativity textbooks focus on presenting the theory in a clean, formal, and mathematically elegant way, often avoiding deeper conceptual issues, ambiguities, or open debates. So most textbooks are not going into the problems with the concepts, and they're not going into the problems where you could end up with ambiguities in understanding it. And they're also not raising issues so that you can debate things. Here are several key points that are often not clearly acknowledged or are downplayed in relativity textbooks. Number one, the role of convention and simultaneity. Einstein's synchronization method using light signals assumes the speed of light is the same in both directions. One-way speed. This cannot be empirically verified without already synchronized clocks, so it's convention, not a measurement. Many textbooks don't stress that simultaneity is defined by convention, not discovered by experiment. So they're letting students get a false idea about that sort of. Sort of like number 2 is the Lorentz ether theory is empirically equivalent. And often they don't talk about the Lorentz theory. The people teaching relativity often say, well, I'm here to teach relativity and not to teach about other theories. And next, issue number 3 is the dependence on coordinate choice. And that's time dilation, length contraction, and relativity of simultaneity of coordinate dependent effects. They're not directly observable in an absolute sense, but appear due to the way events are described in different frames. Textbooks often present them as real effects without emphasizing they depend on the observer's coordinate system. So number 4, relativity and GPS are subtle. Textbooks use GPS as a successful application of relativity, but often don't mention that GPS uses a preferred frame, and it's about synchronization and clock corrections are implemented. This hints at something akin to a practical preferred frame, which contradicts the spirit of a full frame symmetry in special relativity. In other words, they might start teaching the students in relativity course that there's no preferred frame, but actually things like GPS do use a preferred frame. And issue number 5 is time dilation does not equal clocks running slower per se. A moving clock runs slow relative to a specific observer, but in its own frame it ticks normally. Time dilation is reciprocal. Each sees the other's clock as slow. Some textbooks give the impression that a moving clock just slows down in an absolute sense, which is misleading. But I think if you bring in the issue of a preferred frame, then you do have an absolute sense to it. So ChatGPT is not clarifying that issue very well. Number 6, the twin paradox often glosses over asymmetry. The resolution often appeals to acceleration, curved wheeled lines, or space-time diagrams, but it doesn't always explain clearly why one twin ages less, given both experience the as moving. The reliance on switching in inertial frames is not always thoroughly examined. So basically, when they teach about the twin paradox, they don't often go into sufficient detail to properly explain things. And number 7, relativity may be incomplete or approximate. General relativity breaks down its singularities in sort of like things like black holes and is incompatible with quantum theory, so it has problems. There is no definitive experimental proof that space-time is curved in the ontological sense. It's a model, and so they don't explain that to students. What you're talking about is a model. Some physicists explore alternatives, e.g. emergent gravity, ether-like models, but textbooks often present general relativity as the final word, which is false. So number 8 is historical misrepresentations. Many texts simplify the history. They sort of portray the Michelson-Morley experiment as disproving the ether when it doesn't. And you also got the problem of what was Einstein aware of in 1905. And I've dealt with that in other talks about trying to work out what he was working from. And so these simplifications and the way they're teaching the history create the false impression of a sudden clean break. That's between what Einstein's talking about and classical Newtonian physics. And they present that a false impression rather than what it really was. It's a more gradual evolution. So number 9 points out that the conceptual ambiguities are still debated, and that is debated with people who are looking at that, such as philosophers of physics, but it's not debated in the relativity courses being taught to physics students. So what they debate is, what is space and time really? What are they really? And whether space-time is physically real or just a useful model. And then it goes on to how causality and locality work in quantum plus relativistic context. And those sort of things are still debated by these sort of philosophers of physics, but it's not presented to the physics students that these issues are still being debated, and thus giving the false impression to physics students that these things are not debated. So then number 10, alternative interpretations are underrepresented. Interpretations like the Lorentz ether theory, neo-Lorentzian interpretations, process theory, emergent space-time and shape dynamics, and so forth. It's all being missed out. So those ambiguities aren't just philosophical, they create cracks where alternative theories can take root. Here's how each ambiguity or unexplored aspect in relativity leaves room for reinterpretation, including ether theories, preferred frame models, and other frameworks that challenge or extend relativity. Number 1, simultaneity as a convention. That leaves room for absolute time. They don't go into that when they teach physics students. Number 2, this is LET, that's the Lorentz ether theory, equals SR special relativity empirically. And it's a different ontology allowed. So it's a different way of talking about things. It's supposed to be experimentally equivalent, and they don't go into explaining that when they're teaching physics students. Number 3, coordinate dependent effects. That means physics may be frame dependent. And they don't explain that. GPS is number 4, uses the preferred frame, and it's a possible practical ether. And they don't go into that. They miss all that out as well. So number 5, time dilation is reciprocal and contradiction if real. So if you've got two observers and each is saying the other person's clock is slower, that can seem contradictory, and they don't properly explain all of that when they're teaching to physics students. And number 6, twin paradox needs asymmetry, and it implies a hidden frame. So you've got, in the twin paradox, you usually got a twin going off in a rocket and then coming back to Earth and finding they have aged differently. They don't go into the problem of asymmetry and symmetry in such situations. And so the LET, which is LET, Lorentz ether theory, or other models can deal with things better. And so number 7, general relativity GR may be approximate, and that means that there should be maybe in ether gravity theories. General relativity breaks down its singularities and is incompatible with quantum mechanics. This opens the door to alternative gravity theories and involves a medium. That involve a medium, and you end up with these other things like emergent gravity. Number 8, there's historical myths, and you have revisionist theories have space. Once we recognise that the ether wasn't disproved and Einstein's 1905 ideas were part of a longer development, it frees us to revisit earlier ideas. And so often when they teach relativity, they are falsely telling you there's no ether, when really they should be looking into the issue of the ether. Number 9, philosophical ambiguities, and that leads to competing ontologies being allowed. If space-time is a model, not a physical entity, then other models, e.g. with particles moving through a medium, of viable alternatives. And what's listed there are some of the possible things there. So all of that is being missed out to the physics students. Number 10 is the suppression of alternatives implies intellectual monopoly. So when they're teaching physics students about relativity, they're not telling you about alternatives. And that given the false impression that there aren't alternatives when there are. So this is the summary of the things. You got ambiguity with simultaneity is a convention and so forth. And LET, Lorentz ether theory, is empirically equivalent to SR, special relativity, and all these other things here. They're just not being gone into properly when they're teaching relativity. And that's the end, finished. Thank you. So this is the things that the AI has pointed out is that hello, I'm back again. So if I get full screen, yeah. Hello, full screen. So there you go. That's today's session. AI, the AI which I like, ChatGPT, seems to be pointing out all the problems with mainstream physics. And the first session was pointing out that the teaching of quantum physics is bad. And the last video I was pointing out to you again that the teaching of relativity is bad. And so that pretty much sums what the mainstream is. It's just churning out physicists with a bad education about physics. They're not aware properly of their subject because it's been dumbed down to them. Let's see what we got in the comments. If there's anything else come through. So it says, what is the ether composed of? Let's pass on that. Ether is the medium for light. If there is an ether, it must be made of matter. It's the nature of dark matter. Don't know. Pass. So so in the comments between people, so he's saying No, the ether is not made of matter. Matter is made of ether. So, weird. So it's just circular in the end. Just go around in circles when he's talking about these things. The ether must be a unique form of matter. Particles much smaller than electrons, which interact with each other. So I don't think that any experiment has gone into that issue. So it's beyond what anything's got at the moment. Ether is not particular, it's a continuous medium. So not shown by any experiment. Some say the ether is composed of minuscule particles that travel very fast in all directions. Some think electron-positron pairs, some think it's a fixed and stationary, while others think it flows. Well, basically, when you're dealing with physical reality, what you got is just some maths, and the maths is not showing you anything like that so far as I know. Yeah. So Jim says the problem with teaching quantum mechanics is that the theorists don't fundamentally understand it themselves. E.g., Feynman, yeah. And I think that was being pointed out by the video that Feynman was teaching things wrong. And the problem is with this, the theorists, they've gone through an education system of teaching them physics, and the physics is all messed up. So it's just being perpetuated. Theorists don't fundamentally understand it, and it's being taught to them wrong, so that's why they don't understand it. So I'm only picking a few things in the comments because they sort of like going off on their tangent talking about ether. They call it this one. So another example going off at a tangent about ether. If the ether were made of discrete particles with gaps between them, then you would not need another medium between those particles to explain how they interact. So in my view, you're just dealing with a mathematical model, and what's in the mathematical model at the moment is nothing to do with any of that. Gary Question says, I'm actually skeptical that the ether exists at all. Well, I go by definitions, and light is supposed to be a wave, and if you have a wave, you've got a medium. Light medium is called ether, so by definition, it should exist, even if we don't really understand what it is. Yeah. Jim says, ask ChatGPT if Einstein's 1905 special relativity referred to Michelson-Morley experiment, even if he didn't explicitly cite it. Well, I've gone through Einstein's first paper on special relativity a lot, and he doesn't mention the Michelson-Morley experiment. So I think I would just say the same thing, that he doesn't mention the Michelson-Morley experiment. there's no quote we got in the paper saying from Einstein talking about the Michelson-Morley experiment. In the papers about Einstein, when they asked Einstein about whether he knew about the Michelson-Morley experiment before 1905, they asked him that question, and at one time he said he didn't know about the experiment before 1905, and another time they asked him, and he said, yeah, he did know about the Michelson-Morley experiment. So you've got ambiguity from Einstein as to what he remembered. So it would have helped if his special relativity paper had referenced what he was working from, but it didn't. You have no citation, no references from what papers he's working from, because you got him mentioning Maxwell and I think Lorentz, but he's not saying where he read that information from about those things. So you got no reference of, if he did know about the Michelson-Morley experiment in 1905, got no reference from him saying where he read that from or where he knew that information from. So it's all just, with Einstein, it's all just ambiguous. Plus, as you go through the paper, I've used AI on the paper, and AI points out there's a lot of mistakes made by Einstein in that 1905 paper, and I presume it's the same thing with his other papers. There's lots of mistakes in them. I think next one is solidness exists in a way as a line between two energetic substance pressures, though asymmetrical and self-similar, self-transforming as a whole, directional. So I don't know. So solid, something solid, it's supposed to be made out of particles. Matter is supposed to be made out of particles. What else you can say about it? Don't know. Yeah. No, this one says ether, or whatever name we call it, definitely exists. We could call it light medium. All interactions could not happen without a mediator. So yeah, I would say that you're probably right. If light is a wave, then by definition, a wave has a medium. So there we go. So how does the ether cause gravity though? Oh. Well, we got a problem with how physics has developed from about the time of Einstein. Einstein comes up with his paper on special relativity in 1905. Then he comes up with general relativity in 1915, dealing with gravity. And then later on, about the 1920s, they came up with quantum physics from people like Niels Bohr and Heisenberg and Schrödinger and so forth, which Einstein started to disagree with. But it all ends up as a total mess. How does anything connect to anything? If you're going by the mainstream point of view, many people in the mainstream say there's no ether, so it wouldn't connect to gravity. But as I've tried to point out, that really you should be understanding relativity as having an ether. And that would be called the Lorentz ether theory. And how you tie that onto gravity is another problem, which we'd have to look at. Right. Try my father's Tron theory on VIXRA, and that's a place where a lot of physics papers are stored. The first level ether particles composed of smaller particles that also fill the space between them ad infinitum. It goes on for infinity, eh? Okay. There's an interesting, goes on a diversion here, interesting New Scientist article just come out, I think, saying about some mathematicians don't believe in infinity. So that's something else I need to look into later. Okay. So SCID says, under my profile name, there's a link to my paper. Everything is answered. Gravity emerges from ether, accelerating through matter density, generating pressure, driven force, differential. So, and that's where we dissidents normally we start off, I think, by doing these physics courses, and these physics courses are dumbing things down, and they're so distorting things, making everything wrong, telling us things that are wrong. And so us people have gone through that. We then recognise that what we've been taught as physics is wrong. We then become distant, and we then start forming our own theory. So 100 distance, suddenly there's 100 different theories that each form their own theory. And so we're not really building anything as a collective. There's lots of theories out there. So everything is fluid dynamics, that's nature. Things are solid as well, aren't they? Fluid counts as gas and liquid, so that covers that. But solid, well, things are solid, they're not flowing so much. So it seems to be. You mean on your YouTube channel? So, and SCID says yes. So information on his theorizing seems to be on his YouTube channel. What's the Z? My computer phone. Following on from that, Question says, I tried to find your channel, though it didn't show up. Yeah. So Jim says, even a continuous fluid medium is composed of particles, e.g. water. And it means probably water particles, water molecules, water atoms, hydrogen and oxygen atoms, and so forth. So I think that's it. That's the end of the comments. Let's see what this next one is. Jerry, don't know what that is. So I think I caught up to date with the comments. A minute. Next, there's more. Okay. So go back to what SCID says. I've included some mathematics for good measure, but it's absolutely not necessary. Physics should be able to explain plain working language. If it can't, it's simply wrong. Don't know. Usually, from the point of view, when they're teaching physics from a descriptive angle, they like to present it as being mysterious. So Einstein got form and substance reversed in his equation. Don't know particularly what equation. Maybe it's the famous one, E equals mc squared. I think that'd be a different session to go into. Oh, find a lot more comments here now. Let's see. I would agree to a large extent math is often something of formality. Yeah. Mathematics is everything. Mathematics is everything because you are, as a physicist, you're supposed to be doing an experiment and you're making measurements. You're collecting data, and the data has numbers in it, and you're trying to connect those numbers together. That is mathematics. So you've got mathematics. As a fundamental part of physics, you've got mathematics. All black dark things, as Mason put it. Oh, a dogma. Don't know. Next. Hey, I got somebody say something to me. Question. What would you say causes the WFC? I'm not quite sure what WFC is the wave function. It's just mathematics. You're just talking about the wave function. Okay. So, not Solomon Fish explains mass being form and light speed being substance. So, where that's connected is by Einstein's famous E equals mc squared, and I don't know about that interpretation of it. SCID says a true ether model should stand independently of the convoluted frameworks of quantum mechanics and relativity, not attempt to reconcile with their contradictions. Well, in my relativity sessions, I have tried to point out that really things should be understood is that there is an ether. So that would serve as a correction to relativity for the people who believe that relativity has no ether. And to say that there is an ether would serve as a correction to the relativity that those people believe in. So that would reconcile some of the contradictions in relativity. And then if you're trying to combine it with quantum mechanics, that corrected relativity would probably sort out some of the problems of combining quantum mechanics and relativity just by introducing the ether. I don't know. So not Salmon Fish says the wave is true form between substances. It's the mass. Don't know. Visibly obvious, otherwise the wave is impossible geometrically, having no thickness. Well, if you go to geometry, the usual geometry comes from the Greek mathematician Euclid, and it starts off you're forming things from points, and points don't have thickness or anything. They're just dimensionless. But then if you join a line, if you can form a line from points, then you have a length, so that's a dimension. And if you connect different lengths together, you could form an area. And if you form different areas together to form a cube, you've got a volume. So suddenly, from starting from a point which has no thickness, you've suddenly created something which does have thickness. And that's just basically form geometry. So Jim says, when I asked AI, it said he effectively refers to it when he cites evidence that the two-way speed of light is constant. Effectively, well, that's so Einstein, for a start, does not use the term two-way light speed. He doesn't use that term. And that, if you're talking about his 1905 paper, he does not use the term two-way speed of light. And that's a later interpretation by people who believe in relativity that came after 1905. So it's something being imposed on the 1905 paper that what Einstein was talking about was the two-way speed of light when he was referring to light speed being constant. But he didn't talk about it that way. Einstein talked about light speed being constant. He didn't say it was two-way light speed. So if he's getting that from the Michelson-Morley experiment, then he's not saying that as well. So if you're saying, he effectively refers to the Michelson-Morley experiment when he's talking about two-way light speed, well, he's not talking about two-way light speed. And he's not explicitly referring to the Michelson-Morley experiment. So as far as I'm concerned, it's still ambiguous. So, next. So Question says he still can't find SCID site. I couldn't find your site. Maybe it's shadow banned. It's got such good information on there that somebody in Google has shadow banned it. Conspiracy theory. Don't know. So Roger, what would you say causes the WFC? I think when you say you might be referring to the wave function. Is that what you mean by that? So it's just mathematics. So what causes mathematics? Nothing causes mathematics. Mathematics is just there. I'm saying, not someone Fish says, I'm saying solidity has no thickness. Solidity is more the boundary, the edge. I don't know. Don't know. Things are seem to be going off on a tangent again here in the comments. So another comment by not salmon fish. Do you think the core of the coffee cup in your hand when you imagine it has a solid object? Lost me there. I don't know. So it carries on. The internal solidness is moot, just like electrons in a wire. Don't know. Lost. Don't know what it means. So what's it? Get this question on. He says, I would agree that maths is crucial sometimes, though. My physics is mainly about experiments, and you got maths. If you're not doing that, you do something else. I don't know. Got comments here by not salmon fish, and don't really know what they're supposed to mean. But to the point of the stream, dual slit, it's neither particle nor wave. The line pattern is when two transferences interfere. It's a 0.5, not a particle, and not a wave per se, because spaces matter. Well, it's a wave function, it's mathematics, really. So, Jim is saying from the 1905 paper, as it got here, this is the Einstein's 1905 paper. Yeah, that is the one of the translations of what Einstein is saying. Einstein wrote his 1905 paper on special relativity in German, so it gets translated into English, and there are various different English translations, and this is one of the translations. This is Einstein translation in English. In agreement with the experiment, we further assume the quantity, and that's that math equation, be a universal constant, the velocity of light in empty space. And the problem there is, one of the problems is the word velocity. In the German, it's a bit ambiguous whether you should be using the word velocity or speed. But anyway, put aside that, he's definitely not using the term two-way light speed or two-way velocity speed. Or two-way, and he's not using the term two-way. So if you're getting two-way light speed from that, well, Einstein's not using that term. And if you're getting that equation from Michelson-Morley experiment, Einstein's not saying that's where you got it from. Next one. SCID says light, HT, is not something that is emitted or radiated from a source in the way mainstream physics describes it. Instead, light is the dissipation of energy through the ether, just as heat is. Well, the issue that physics is based on experiment. If you got something like a torch, you turn it on, and the light beam does then move outwards. So you kind of like, oh, the light is here one moment, then it moves on to somewhere else further on. So you do treat it as like it is something emitted. You turn the torch on, and light is emitted. And that's the way we talk about it. Yeah. So Jim is referring back to that quote from Einstein. And he says that's where he refers to two-way speed of light. And as I pointed out, Einstein does not use that term. You go to the German, there's nothing which you can translate from the German into the English saying he's talking about two-way speed of light. It's something that gets added later. People have read Einstein and they think, oh, he must be talking about two-way speed of light, even though he doesn't use that term. So next, SCID says the energy transferring inside us is the same that propagates outward as light, adjusting to the properties of each medium it moves through. So the energy is transmitted, light energy is transmitted. So, next, those new solid state batteries, vacuum gaps, as superconductivity, meaning spaces. I think that's absolute exclusively like lithium. Don't know. Don't know. Say things that don't know what it's supposed to mean. He does describe the two-way velocity. I think that's probably Question is referring to, or what Jim is referring to. And if he's referring that, if Einstein is referring that in his 1905 paper on special relativity, then Einstein is not explicitly stating that. It's an interpretation. I don't know. I don't think anything is really relevant. Go through the comments. So we go to this one. Magnetized rubber as waveguide. We're just going off in so many different tangents here. It's not really connecting to what's I've dealt with in this session. So there, I think I'll end it here. Magnetized rubber. So that's the end of this session. Thank you very much for all those attended. Sorry for the delay in starting up. I think ideally we were late starting, and ideally we would finish at 5. So I've overrun my 5 o'clock finish time. Okay, next one. Thank you, Question. Thank you, and good night. He's another comment here. Thanks for everyone else. Yeah, thank you, Question. Thanks for all those attended. End of session. And so basically, it's been a complaint about the mainstream educators. They're teaching bad physics, basically. They're teaching bad physics in quantum physics, and they're teaching bad physics for relativity. It's all just a total mess. End of session. Thank you.